Hello everybody, Jake Raby here, Flat 6 Innovations. Want to bring you into our world again for yet another RenVision technical video in our Focus on IMS Bearing Failure series. Now in this particular part of our series, we're going to go over the component inspection of our 29,000 mile engine that was owned by the original purchaser and suffered an IMS bearing failure at 29,000 miles. So what I'm going to do now is something we've never done before. This failure assessment, basically component inspection and failure assessment, is going to go over all the internal pieces of the engine as a whole, and then we're going to basically put those in two groups. One, something we're going to reuse with our modifications because we are building this into a Flat 6 Innovations R40 Street and Track Performer. Now, that is a Stage 2 based engine, okay? But it's the R40 version. So if you're looking at this, you might have one of my regular Stage 2 engines. Some of the things we're going to talk about don't really pertain, so don't be asking me questions about that and blowing up my email. Unless you purchased the R40, this does not reflect directly on what would happen to your engine. And moreover, unless you purchased the R40 after a resultant of a IMS bearing failure, it really would change as well. And the other side of things is going to be what we're going to throw away. So one, what we're going to keep, and then two, what we're going to throw away. What we're going to throw away, we're going to do some kind of colorful stuff with here at the end of this video. So I want to get started and go over what actually failed as our primary failure, and then what the collateral damage was, the secondary, tertiary damage, and it goes on down the road, okay? And what you have to understand is the primary failure in this case was less than a $30 bearing. The factory IMS bearing is a less than $30 part, and that is what failed. That was your primary mode of failure. That led to a string of collateral damages that ended up resulting in the entire engine having to come apart to address them, to get the debris out, to assess the wear, and really kind of reconstruct the engine. What we're doing is required. I don't want anybody to look at this and think, oh, those guys could have just cut that old bearing out, threw another one in there, and went on about their business. That couldn't happen, and the reason why is because in our last video where I tore the engine apart, you actually were able to see that this tensioner paddle had snapped, okay? So this goes together like this, and this IMS drive chain tensioner paddle failed as a result of the IMS bearing failure. So this is probably the determining factor for the fate of this engine, was the fact that the collateral damage stemming from the trauma that came from that bearing failure snapped this in half, okay? So we see people all the time that will go in, try to cut the bearing race out, which I want to go over in a minute, and put another bearing in, thinking that the bearing is the problem at that point. That's not the case. This isn't elective anymore, guys. Pulling the bearing out is the least of your problems now. We're going to take that shaft and we're going to crush it with a tank because it doesn't need to be ever tried to be reused again. That shaft is junk. There's no elective. There's no nothing anymore. It failed. So in this case, if somebody would have tried to cut the bearing out, put another bearing in it, try to think they had this mindset where you could change the oil 20 times and get all this ferromagnetic debris out, that would be limited because as soon as they tried to put it back together again and put the IMS drive chain tensioner in place, the hydraulic tensioner, they would see that this tensioner paddle that rides against that had snapped in half. This is the determining factor for the fate of this engine, and this collateral damage is what made the entire engine have to come apart. You could not patch this one up, okay? The guy working under a shade tree or with a dirt floor or whatever the case may be that doesn't know this engine could not have patched this one up. This one was dead. So I've got the engine laid out basically from the deepest part of the heart here on my lift, if you will, made it into a table so we could lay everything out. We've got the deepest part of the heart here, and then behind me I've got some more of that. And as we go down the line, we're going from the inside of the engine out to the cam covers, valve train, that sort of thing. So we're going to start at the heart of it, show the primary failure, and then work our way out to the outer extremities, just the way that all the debris would if it was in the engine. It's going to come from the very bottom, it's going to work its way outside. Now in the teardown video that you saw prior to this one, basically you were able to see some of the debris we found out in the cam covers, and some of that we had in there as some B-roll. That is all stuff that stemmed from this primary failure of the IMS bearing. So taking us back to IMS 101, this is the intermediate shaft. IMS stands for intermediate shaft, okay? A lot of people think this shaft has a problem. The shaft doesn't have a problem. Yeah, we've seen a couple of these shafts separate over time, things like that, but the shaft itself really doesn't have a problem. Sometimes the gears will slip, throw the cam timing off, nothing catastrophic. This shaft really doesn't have a problem. The fact that this engine has an intermediate shaft is also not a problem. Guess what? All your Metzger air-cooled Porsches, the GT3, the turbo, they kept those intermediate shafts in them for many years after the M96 engine, M97 engine had been taken out of the equation, okay? They kept them even after the 9 Alpha 1 engine was introduced in the basic Carrera. There's nothing wrong with an intermediate shaft. I think it's an essential item for most of these engines, and I think it serves a role that we're seeing cause problems with some of the engines newer than 2009 where the intermediate shaft was replaced. We've been seeing those for a while, and they're starting to increase, okay? So the problem is this bearing, okay? This bearing, of course, going back to IMS 101 and going back to my 4-part series that we did in conjunction with Porsche Club of America back in 2017, where we go over the things about this bearing, how it fails, what it is, the kind of bearing it is, how to address it. This bearing is the problem. So I don't want to sit here and shed all the light on this, because even though this is a focus on IMS bearing failure, we have done this in many other videos. So if you go on YouTube, Google PCA IMS, you'll see myself and Vu Nguyen, who is the executive director of PCA. I was asked by PCA and some other people to do videos and work along with them to do this, and we conveyed all these points about the IMS bearing that needed to be conveyed. It's a very generic video, but it explains the problem without as much explanation on a lot of the ways that even I have invented to fix it. It wasn't about the fix, it was about the problem. People can come up with their own ideas about which way it needs to be fixed, okay? I'm the originator, I'm not the imitator, we're not the copycats, we're the guys that set the bar. So of course I have my own ways of thinking about a lot of this. We conveyed the generic information in that series of videos, and you need to watch it, okay? So primary mode of failure here, bearing has failed. Now, with the bearing failed, we have debris. And this debris that was generated is what you see here. We have balls, we have parts of the snap ring, we have pieces of the inner race, we have a lot of this. You see how this screwdriver is magnetic. It's picking up all this ferromagnetic debris, okay? And even, see, it picks that up. This ferromagnetic debris is very harmful to the engine. And if you don't take the engine completely apart, and you don't ultrasonically clean it, and you don't thoroughly go through and clean every one of these components, you're going to have a problem when it goes back together, okay? We have 3 ultrasonic cleaners here. They're very powerful. They get hot. They have certain solution in them. These parts are washed at a minimum of 3 times between disassembly to reassembly, no matter what, to help remove all this debris, okay? The debris retention in this engine after a failure like this is extreme. So again, your bearing fails, that is the least of your problems. The most of your problems now is going to be making sure all of this debris gets out of here. The bent valves that were a result of the failure are taken care of. The timing chains and all the other components that were basically impacted by this are gotten out of the equation. Those things need to be your number 1 focus, because you've got one chance to do this right. If you cut corners, guess what? You're going to get to do it all over again. So primary failure IMS, now let's look at everything else and let's grade the rest of these components. And basically after I've gone over it, I'm going to tell you whether I'm going to keep it or not as part of my R40 process. So one thing I noticed here, and we actually have interviewed the owner of the car now, I gave him kudos about the way he drove this car. He obviously was not somebody that rode the clutch a lot, 29,000 miles. This is one of the thrust shims, basically. This fits here in the carrier, okay? And it helps to set the end thrust of the crankshaft. There's two of these. One goes on either side of this centermost main bearing saddle, and they are what set the end thrust. So these are a part that we do replace. We also use a special coating on these that helps to keep them from wearing prematurely, and that coating is something that, as far as I know, nobody else does in this industry. This also is one of the newer types of thrust shim that has 3 oiling grooves in it. The earlier ones only had 2, which this engine is actually a fairly early M9603, so I would think that it actually would not have those 3 grooves, but it's nice that it did. That's probably one reason why these are not very worn, plus the fact that he didn't ride the clutch, he didn't set at a traffic light with his foot on the clutch, he didn't set at stop signs with his foot on the clutch or in traffic, and we can tell that. So kudos to the driver, he knew what was going on. That's a part that we're going to throw away. Of course, we have this IMS tensioner paddle, and yeah, it's going to get thrown away. As part of the R40 process, I'm replacing this with the LN Engineering billet tensioner paddle. That is another Raby development. We came up with that back in 2007, and I've used it in all my R40 engines since then. It's been an option on a lot of the Stage 2s, and a lot of times in the Stage 1s, we will go back with an original equipment one of these. That's just a newer one, okay? But I like to replace this with a billet one, so again, we're going to crush that with a tank also. Here we have inside this carrier, this is the crankshaft carrier, okay? The crankshaft actually will fit into this, and I'll show you a little bit about how that works just to give you a better focus on this. So the crankshaft fits into the carrier like this. The carrier is a subcomponent of the actual crankcase. Now, what's interesting about these engines is the carrier is what the cylinder heads bolt to, believe it or not. This is at the heart of the engine. So as you bolt cylinder heads on, those cylinder head bolts don't go into the block. They pass through the block, which houses this carrier, and those fasteners will actually go into the carrier. Okay, unique thing, people don't realize how this works. So this carrier is an important part of the engine. As a matter of fact, I consider the carrier to be the engine, because everything goes around this, and this is the strongest part of the engine, okay? So we'll pull the crankshaft back out of here, and we're going to discuss the bearings. Now, none of this stuff has been washed, guys. Once we get done with this video, I'm going to take all the stuff we're going to crush and crush it. The stuff we're going to keep, we're going to wash it in ultrasonic cleaner and look at it even closer, okay? Because we have to start grading it. We have to magnaflux some things. There's a lot of things we have to do. But nothing's been washed. That's the key here, okay? So I just want to wipe a little bit of the oil off some of this. I wanted to leave this as virgin as possible as I could, obviously. Now, in our interview with the owner of this car, the prior owner, because I did purchase the car from him, he did purchase the car new. In our interview, he did state the fact that this engine has never seen the track. He had it to 130 miles an hour or something like that one time. It has been basically over-maintained over the years, and he did everything right. So looking here, we can see we have our main bearing inserts all the way down this tunnel here. And we notice that this one has a slightly different color. Now, this is at the front of the engine. This would be the crank pulley end of the engine, okay? So this one has more wear on it noticeably than all the rest. A lot of these look like they're new, especially this one here has hardly any wear. This one has hardly any wear. As we go down, we see a little more wear in the center here. and then hardly anything in the rear. Now, here in the rear, I can tell you clearly this has never been a track car, because if it was, this rearmost bearing is the one that sees the most amount of load from the flywheel and the clutch assembly being thrust forward and aft during hard acceleration. It's also the first one that starts to see if you have a problem with low oil pressure. Okay, so what we see here, I would consider this to be kind of normal and expected. Now, I'm going to move a couple of things, and I'm going to grab the other half of the crankshaft carrier, because there is two halves. I'm going to set it right here next to it. Spin this around. Okay, there we go. So this would typically go kind of like what I'm going to do here. Okay, that is what forms your crankshaft carrier. That basically your crankshaft ends up being encapsulated by these two clamshells, if you will. Again, I'm doing all this from lay terms for people that don't work with engines every day. So if you're somebody that understands this stuff, don't fault me for being a little bit overboard with my explanations of things. So what's interesting here, if you look at this, we see there's more wear on one side of this bearing than there would be on the other. This one looks somewhat suspect. This one looks perfect. Now remember, these bearings were in service against each other, or on opposing sides of each other. Now if we go back here and we look, we see that the rear bearing has more wear on this half than the opposite side of the carrier has, which is kind of interesting. So what we have to do in this case is we have to do some extra sleuth work, if you will, to go in and do some precision measuring to make sure that the factory actually machined this properly. Or did they machine it where the crankshaft did not set perfectly square inside this housing? Okay? These are some things that we have to look at. If that happened, it's not very much at all. It's obviously not enough to cause an IMS bearing, so don't start thinking about that. Don't start thinking about an IMS bearing failure happening from that. What I'm getting at is we're just grading these components. Now these are bearing inserts, okay? So we can take a bearing insert out, just like this, okay? And we can replace it, which is what we're going to do. We're going to go one step further than that, and we're going to use a proprietary coating that's been done by a couple of different coating companies for us over the years, and we're going to use that coating to add a secondary layer of protection against oil starvation and things like that that could make this bearing wear early. So that coating helps to add lubricity. It helps to create a little bit extra insurance level, if you will, to this surface, because the coating has to be compromised completely before the bearing starts to wear. So one thing I want to show you here is you see these two little marks. We see these kind of all throughout. You see a couple little marks. This engine had such low mileage on it that it actually, you could still see where the factory precision measuring devices were used to measure the running clearances between these parts. That's unheard of that we are able to still see this, okay? Very low mileage. And the wear that I see here does not tell me that we have any major problems, okay? It also tells me this engine shut off really soon, because if it hadn't shut off quite so soon, we would see a lot of scoring happen with this where metal would have ran through these surfaces. But honestly, the only place I see that is maybe a little bit here, and of course this one that we're talking about here that had more wear on it, okay? So we're going to take these bearings out and we're going to grade these very closely. We're going to look at everything about them, and then we're probably going to clean this all up and put it back together again. And sometimes they're more pesky to get out than other times, especially wearing gloves. But we're going to clean this stuff up, put it back together, and then try to determine if one of these may have had tighter running clearance from the factory. I've seen that sometimes where one of these saddles will be tighter from the factory than it's not. In that case, we developed a procedure to restore the concentricity of these bearing housings and make sure that we don't have that problem moving forward, and we can also adjust that running clearance. So none of this stuff here is killer, okay? There's no problems with this stuff. I want to make that clear. This is just some things that we consider. So these are all going to go in that pile of stuff we're going to crush because we're not going to reuse these, okay? The carrier itself, yes, we'll reuse it. We will do the required work to it, whatever needs to be done, and it will be going back into this original engine as the R40 Street and Track Performer. All right, so now let's move down to our crankshaft. The crankshaft is the heart of any engine. It doesn't matter what it is. If it's a two-stroke dirt bike, if it's a chainsaw, if it's a Porsche, if it's a tractor, it doesn't matter. The crankshaft is always the heart of the engine. And this one is beautiful. These journals are impeccable. Even here on the front, which would basically have gone in conjunction with this wear we see on this one bearing, which again is not bad, it's just something notable. Even that journal looks like it's brand new. Yeah, 29,000 miles, what would you expect, okay? This is something that makes the Flat Six Innovations program a little different than everybody else because you get your engine back, right? We're not just going to take all this, throw it in a pile, and you get somebody else's stuff. We keep your stuff with your car, with your engine, and you get all of your items back, what matched your car. We're not in the business of swapping stuff in and out. This is not a wham, bam, thank you, ma'am, fast food type thing, right? This is like you sit down and you have somebody, cook you a steak to order. But we're going even further than that because we take it to the point where we would grow the cow. We would raise the cow to cut that steak from. That's the kind of level that we're doing here. So you do get your stuff back. So an engine like this at 29,000 miles with this perfect crankshaft, that's a benefit versus a mass producer that would do something generic and you might get a crankshaft out of a 200,000 mile engine. It wouldn't be yours, it may be somebody else's. But all this adds time to the build. So one of the things that can happen as collateral damage to these crankshafts is when the IMS tensioner paddle breaks, which you've already seen happen, that was this component here. When this thing breaks, then it basically relieves the pressure that's driving the intermediate shaft from the timing chain. So this main timing chain that drives the intermediate shaft goes around this sprocket here. Now this is an internal tooth chain. That's the terminology for this, okay? And with this chain, it has a lot of attributes. It's very strong. I've only seen a couple of these break. I have seen them wear and cause some weird problems and make some noises, but I've only seen 2 of them break. And this chain is both good and bad during an IMS bearing failure. One, the chain itself kind of helps keep the intermediate shaft somewhat centered so it doesn't do a lot of damage to the case when it comes loose because it is so strong. But the problem with it is it has these teeth inside, and the teeth are very sharp. You might be able to see that in the camera. And it's just a whole lot of teeth that have not as much contact area as like a roller chain would have, right? Well, the issue when this chain starts to flop around during an IMS bearing failure is it can destroy the crankshaft. So we've seen these before where you pull your finger across it and it's so sharp it'll cut your finger. This one, we're very lucky because it's perfect. I've seen a 29,000 mile crankshaft like this, or even my record's a 12,000 mile crankshaft that had an IMS bearing failure basically take it out, where the chain killed the crank. It was beautiful in every way. It had nothing wrong with it, but it couldn't be reused because that drive had been taken out because the chain took it out, okay? This one, I believe that we dodged a bullet. We're going to have to further inspect it, wipe it down closely, ultrasonic it, all that sort of thing. And when we're done with that, we're then going to have it magnaflux tested. Now, that's a magnetic test that looks at the core of this crankshaft and tells us there's cracks inside of it. Yes, we've seen crankshafts that are low mileage like this fail that test, okay? Not sure if that was taken out by collateral damage or if it was a part that had some other failure happen to it earlier on or just bad luck. But we never assume anything and we quantify everything. So as part of the R40 package, that magnaflux would be a priority with that. And as soon as I'm finished with this, it's going to go straight out and have the magnaflux testing done. So if you want to look that up, it's magnaflux. It is considered a non-destructive type of inspection. and it's been used for decades in motorsports and everything else. So yes, as long as this passes the MagnaFlux test, as long as it's still concentric, it's not bent, doesn't have anything weird going on with it, then this will be getting reused in the package. Now we are going to dynamically balance this crankshaft as well as the rest of the assembly. We're going to take that to a much tighter race tolerance that we do in-house on our own equipment here that we've been doing for many years. And when I build this engine, guess what? I'm going to be the builder, and I'm also going to be the machinist. I'm going to be the balancer. I'm going to do everything with this. When we build an engine here, once I assign a builder to it, that builder does it all. He takes it apart, he builds it, he assembles it, he does everything. He even puts the key in it and starts it up for the first time. So crankshaft, heart of the engine, I believe it's going to be fine, but we will have to see. Okay, so these are our crankshaft carrier bolts. These actually pass through the carrier, and they are what hold it together. These are a TTY, or a torque to yield bolt. We're going to replace these with a higher performance version. That's part of the R40 package. Not all my Stage 2s get that. It's an option with some of them, not all of them, but the R40 will get these basically ARP fasteners that LN Engineering and I had ARP make for us a few years ago. And I do like using those higher performance bolts. They are not a torque to yield. They have a standard torque value to them, and they are, to me, a much better bolt for an application that needs them. So this engine is going to make a significant amount more power than factory. I'm not going to tell you exactly how much that's going to be because this engine has to prove itself to us, okay? It will just be a significant difference going from a 3.6 liter to my R40 4.0 liter, okay? So these are going to get thrown away. They're going to get crushed by the tank a little bit later today. There's no damage with them, but to me, they're just not weak enough, or they're too weak for what we're going to do. So now, let's talk about connecting rods and pistons. So I'll get the other three connecting rods. Now, these rods are what we call a cracked cap technology. So this came around in the 90s. A lot of manufacturers were using this, and the idea behind it was basically you make this connecting rod, and it's all made pretty much as one piece, and then you engineer a couple stress risers in it, and you strike it, and it breaks. When it breaks, there's no two breaks that are the same, just like there's no two snowflakes that are the same. So the idea is once this thing is broken, then it only goes back together exactly as it broke. That's the idea behind this. This made things cheaper to manufacture because there was no precision, not as much precision doweling and things like that in alignment as there was making rods the old-fashioned way. So this was a much cheaper way to go. Most modern cars today still use crack cap technology. Some people are going to look at it and say it's fine, okay? And for limited power outputs and people that are not going to go the track, I also don't think there's a lot wrong with keeping these rods in an M9X engine. And some of my Stage 1 engines still keep them. But those Stage 1 engines have a limited bore size, and they also have a limited power output. And that power output is basically determined and capped based on the fact that we're saving about $1,500 as well as some extra money by not replacing these. So as part of the R40, we're going to use an LN Engineering Flat 6 Innovations developed connecting rod that has a specific weight and length and housing bore size to get rid of this cracked cap technology and replace it with the older version, like most race engines would have, where you have dowel pins here and precision honing and a lot more of a custom type of connecting rod. I've seen these connecting rods break. Some people look at it and say that can't break. I've seen them snap in the beams with no other failure causing it, okay? I've had the cap, or the top of the beam pop off. We've seen them snap right here, seen them snap right here. Usually those failures are a result of something else. But yes, I've seen the beam of this connecting rod break. This is the only connecting rod in my lifetime of building engines of all kinds that I've seen break in the beam. So it can happen, okay? Everything from dirt bike engines, Briggs & Strattons, pretty much everything. I've never seen a rod snap in the beam like I've seen one of these. Who knows why that happened, but it happened. So a stage 1 engine would have a possibility of keeping these rods after they're magnafluxed. We're going to magnaflux them. They could be cracked and we can't tell it, so just like the crankshaft, we're going to magnaflux it. If it comes back good, then we're going to do some extra precautionary work to it, and we're going to fit it with some ARP connecting rod bolts, okay? Not the factory rod bolts. We're not going to reuse these in this engine. Even a stage 1, we wouldn't reuse these, okay? So that's the deal with the connecting rods. Now, the bearings are inserts, obviously, just like the main bearings were, and they look great, okay? They really do. No problems there. Now, just like in the teardown video, I did show you guys where each connecting rod had a wear patch. The rod bearing that come from the top of the beam, basically the rod bearing that was in this connecting rod or any connecting rod and was in the top portion of it, always has a wear patch right here. Now, there's a reason why I think this occurs, but it would lead us down a rabbit hole that I don't want to go down, where I'm going to be arguing with people that don't build engines every day and don't see this stuff, and they believe what they read. But basically, there's a reason why this wear patch is pretty much consistent with every engine we take apart. One of those reasons could be detonation, because you have a lot of load being compressed down this rod beam during the combustion cycle, and that puts a lot of load in this very portion of the rod, and that is transmitted into the bearing. So if that's the case, then why is the load or the wear off to one side from center? It's always that way, okay? And like I said, I've got some reasons why I think that's the case. At the end of the day, what you need to understand is the bearings we're going to reuse with this engine are going to have another proprietary coating put on them, okay? And we are going to size them to the new rods, and we're going to set our own running clearance. We're not just going to bolt this thing together. We're going to set up all the running clearances and build it like a race engine. And I'm not doing that just because it's an R40. I'm doing that because we've got to make sure that all the running clearances between these components is adequate for proper lubrication. Otherwise, we're going to end up with weird wear patches and things like that, okay? So these rod bearings are, again, something else that we're going to crush, okay? And, of course, we're going to crush these connecting rods too. So another big consideration or concern that all M9X engine owners have is bore scoring. Obviously, it's the thing that is driving our business right now more than anything. And this engine, having only 29,000 miles, these are the original pistons out of it, and we did not see any notable bore scoring yet. We saw a couple of hints of it, and we actually saw that the pistons saw the biggest amount of damage from this particular failure because each piston was kissed by the exhaust valves. If you see this shiny little area here, each and every one of the pistons that we pulled out of this engine did see some piston-to-valve contact, okay, on both banks. Totally and completely normal and expected with any IMS bearing failure, okay? I was actually a little surprised that the only thing I noticed with these pistons was that we had this one wear patch here that had really lost its concentration of the piston skirt coating. So this skirt coating you see is a discoloration here, or a dissimilar color, is honestly the thing that is made to sacrifice. It's a sacrificial component. And in this case, it did sacrifice, and it can lead to bore scoring. So bore scoring is a collateral damage that we believe starts in association with a loss of this skirt coating. So as the skirt coating is lost, you have aluminum on aluminum, basically, aluminum pistons, aluminum bore. You have that wear start, and that is what really jump starts the bore scoring. If you want to watch our bore scoring series, a focus on bore scoring, you'll be able to see that, okay? And there's about 7 hours of content, 10 videos in that bore scoring series, and it'll explain a lot of stuff about this that I can't explain today. But these pistons had quite a bit of burned oil on top of them and things like that. Obviously, this is a 29,000 mile car. The owner admittedly did not drive it hard enough. That's one thing that lets all this stuff get caked up here. Also, modern fuels are adding to that and things like that. So, that piston's pretty dirty for 29,000 miles. Not the dirtiest that I've seen, but, as we say, he needed to blow the carbon out of it. It needed to be beat on some, okay? So the pistons in this engine, some people would reuse them. Most people would reuse them, and they wouldn't even think anything about this skirt coating missing because they don't understand how this works. With me, they're just one more item that we're going to crush. We're going to replace them with a 101 millimeter version of this from Ellen Engineering. It comes to us from CP Pistons. It's a piston that we had designed along with Ellen Engineering. It's proprietary to their R40 engine along with its proprietary ring pack and even the cylinder hone that goes along with that. Crankshaft scraper, this basically goes at the bottom of the crankshaft carrier. It's a plastic item. It helps to direct the oil flow away from the crankshaft, keep windage down. So no problem, we'll replace these gaskets here and then we'll end up reusing this piece. Unless something happens with some massive collateral damage, that crankshaft scraper is not a structural item. Timing chains, this is M9603 engine, so it is known to have some timing chain issues. I've seen these engines lose the roller wheels basically from the timing chains. With this one, I don't see anything jumping out at me. They did see a lot of trauma because we did have an IMS bearing failure. I would never think to reuse a timing chain in any engine, so we're going to crush those two. That goes in our crushed pile. This is the guide for the IMS, the other side of the IMS tensioner. So basically the tensioner goes here on this side, the tensioner paddle that broke. This is a plastic guide that is sacrificial. So it's another one of those items that's cheap. We replace it with all of our engines. It is a chain guide, so it will see some wear. This one here has a lot of metal embedded in it that came from the failure of the IMS bearing when that IMS shaft started flopping all around and the drive chain started flopping all around. It was part of the damage alignment for that. So we're going to be throwing that away. We'll crush that. No big deal. All right, so down here, we're going on to our crankcase. And again, I didn't want to wash anything up, but I want to kind of show you these bores a little bit, and they really are beautiful. I mean, it's kind of a shame with this one that we're going to put nickeys in it, if you will. The only reason I say that is because this is the only block that we've probably seen in the last 2 years, even elective jobs that came in that didn't have some level of bore scoring. In this one, I mean, there's not really any scratches or anything here. I mean, the light barely picks anything up. So what we're going to do with this crankcase is we are going to completely process it. It's going to go to Ellen Engineering to have the nickeys process done. So basically, everything that you see here in this cylinder from the water jacket up is going to be replaced on this side with a billet cylinder. Okay, some people call it a sleeve, but that process, that name's been kind of made generic, if you will. So the Ellen Engineering process in this country was the first of its kind, and I think it's still today the only way to go, and all of my engines get it. And I would not reuse this block in any capacity with the original cylinders, even though it looks beautiful today. And the reason why is because I have taken a snapshot of what it looks like today. Why do all this work and replace all these components and do all this extra stuff if we're going to let the foundation have a known problem? We know this block's going to have bore scoring. It's going to happen at some point in time. So why do we limit all the other things we're going to do by keeping this original real estate inside these cylinders, knowing it's an absolute known problem? I'm not going to. Those cylinders will be machined away in their entirety down to the water jacket. They'll be replaced, and then they will be Nickesil plated. So if you want to understand more about that process, again, please look at our Focus on Bore Scoring series. That one goes over all the things you need to know about bore scoring, why it happens, how to diagnose it, what the symptoms are, how to live with it, and hopefully how to avoid it, okay? So the rest of the block will be looked at very closely. Now this block also had a couple of places in it that had been welded, and I'm going to grab the other block half and pull it over here now. This one actually has a little bit more debris about it, so you can see a little bit more here. But what I really want to show you is it has some factory welding done. I can see it from the outside. Not uncommon with these engines. But you see these spots right here? Who knows why, but this block was welded at the factory. This engine had never been apart, okay? So we have to go in and make sure we figure out why they welded it. We have to make sure there's no porosity here, which it looks like a very high quality weld. But again, every one of these engines has to be looked at with a fine-tooth comb. We have to make sure there's nothing there that's going to bite us in the tail after I put my name on it. And it can happen. We can't ever trust any part that any factory gives us. It's just not what we can do. So here, I want to let you note this a little bit. If you look at this area right here, this is where the IMS drive chain was hitting the crankcase. IMS drive chain was hitting the crankcase right here. Now, when the IMS bearing failed, which is located back in this housing area here, then it allowed the IMS to shift over toward bank 1, which is down this direction, and it allowed that timing chain that drives the intermediate shaft to touch the crankcase. So we have to look at that. We have to look at the damage that was done there. How deep is that? Is it just cosmetic, which more than likely it is, or does it have a problem? Okay? So all these things have to be looked at from a foundation perspective. And I consider this like a house. You know, would you want to remodel your house if you knew the foundation was damaged permanently by termites? The answer to that is no, okay? No, if you had any sense, obviously. But we see a lot of people make decisions that are driven purely by the current economics, and you can't look at that. This is an investment. You have to look at it like that. It is a Porsche. It's not a Honda or a Toyota. And you have to learn that either you do it right or you get to do it twice, and I can't say that enough. So the crankcase will be completely processed. The next time you see it, it will not be anything like this. It will be a beautiful piece that has went through a lot of rigors. It'll have my name stamped on it. It'll have a unique serial number on it from my Flat 6 Innovations custom shop, an engine that I built personally, and it will be the way that I want it to be. Moving on down the line, we pretty much got into our cylinder heads and some fasteners for them. These are the factory cylinder head bolts. These are a TTY bolt, torque to yield. A lot of times we do reuse these, even on high performance engines. These bolts do not really have a problem. I've pushed engines past 14:1 static compression ratios with these and have not had a problem with them trying to fatigue or letting head gaskets blow or any of that. But this engine is going to be my R40, so we're going to upgrade that to an ARP set of bolts that actually work as studs that have nuts with them. So the R40 does get that with this particular engine. For some R40s, according to what you're going to do with it, if it's not going to be a track car as much as a street car, then we would just go back with these bolts or give you an option which way to go. With this one, we're going to throw these bolts away. Those bolts are certainly something that you want to throw away every time you build an engine, even a stock one, because they are torque to yield and they are made for a one-time use only. So you don't want to be reusing them even if you're keeping performance low, because that can give you a problem. So we would always crush those. It's just a matter of replacing them with stock, a like item, or going to the ARP stud and nut system. So head gaskets. This engine, the head gasket looks like it's in great condition. We, of course, are never going to keep a head gasket. Nobody should. Most people wouldn't even try. Some people might. But long story short, these are a multi-layer steel head gasket. They are one of the best parts in this engine. They never fail. We've never seen one of these fail unless something made it fail. Like somebody changed coolant, they left an air pocket in the engine, and that started the gasket to fail. But other than that, these things do not fail. So a lot of engines can use a stock replacement for this and have no problem. The R40 is going to get a proprietary gasket that has a special bore size, and it's a different thickness to aid us with setting up our compression ratio. So we've got 3 different thicknesses of those gaskets. They will help us set the compression ratio perfectly for what we want for this engine with its deck height, and its combustion chamber volume, which you would see here. So that gets deep into engine design, but the head gasket helps us set the static compression ratio that I look for with each individual engine combination. So a little bit of technical information about these head gaskets. If you look at it, this is the chain well area. This is where the timing chain passes through on bank 1 and bank 2. And this area is renowned from the factory to have an oil weepage problem. Not really a leak, but it will weep oil because this hole here is where oil returns from the scavenge oil pumps that are in the cylinder head. So a lot of volume of oil passes through this. And there's not a lot of fasteners here. So you see a 6x1 fastener here, another one here, another one here. That's it for this whole chain well in this region. Look how much space we have from here up to the first fastener here. So this whole region here, you can actually see was not sealing off very well. And the reason for that is because the factory should have given us an extra fastener here. Now, there's never a way to really address this problem, so we have come up with a couple of ways to make it better. Some sealants and things that we do during our assembly process, and the head gaskets we use tend to only leak here when the engine has not had enough thermal cycles. It hasn't been hot enough, and basically it has to get hot and cool down for this heat-sensitive type of coating to do its job and seal it off. So if you ever notice a little weep at the bottom of your cylinder head where it meets the crankcase, that's the reason why. So we replace all these with components that we've developed in conjunction with Lynn Hoffman at Hoffman Automotive Machine. Lynn's been doing my cylinder head work at a level that is unparalleled since 2004. And we started doing stuff back with him in the air-cooled days, and he has earned his place as our cylinder head technician. There's nobody knows these cylinder heads better than Lynn. And we've learned about this stuff together. So he learns and gets information from us. We learn and get information from him. Nobody has an ego in the way. And because of that, we're able to learn a lot. So at the end of the day, Lynn is going to remove and replace all of the valve seats in the cylinder heads. Now that is actually the component where the valve touches the cylinder head. There's a seat there that's a dissimilar material, and it's made to take the rigors and the loads and the heat of the combustion process when the valve touches it and cools, okay? So you can have a situation where that valve seat, which is not aluminum, okay, it's able to pop out of the cylinder head, which is aluminum. And that's usually because it was not installed properly at the factory with enough interference fit, or something got too hot, or something happened. So those are going to get replaced. We're actually going to use a proprietary seat with that, and we're going to use a proprietary high-performance valve that I use just in these R40 type engines as an option, okay? The R40 gives us many, many benefits, but there are still some options. Not everybody needs those high-performance valves in an R40. With this R40, I'm going all out. It's getting everything we can throw at it, okay? So if you're buying an R40 from me, and you want these valves we're using in these heads, you'll have to buy them. They are an upsold option, if you will. There's not a lot of options for an R40, but that's one of them. So talking about that, we're going to go to a slightly different valve size. We're going to use a different manufacturer. They're not factory Porsche valves. They are a different weight, all that sort of thing. Then the cylinder heads will be decked. This is the deck surface here, and the deck surface will be changed to alter our compression ratio through your combustion chamber size difference, okay? So when you deck this cylinder head, it makes the combustion chamber a little bit smaller. That elevates compression ratio, okay? That's one of the factors that go into compression ratio, along with deck height, piston volume, and all those sorts of things, bore, stroke, all that. So looking at our valves, if you see this little mark here, this is a witness mark where this valve hit this particular piston. See this shiny spot? Again, these are all clues. So witness mark, these two components hit each other because the valve timing events were retarded, meaning that things were slowed down on the exhaust valve timing side of things because the intermediate shaft bearing had failed, and it caused that retardation, and it allowed that valve to contact the piston. Now, if you look on the other valve, let me kind of clean this up a little bit, don't really see a noticeable witness mark there, but we see a noticeable witness mark here, okay? So definitely that one contacted as well. We look at all six pistons have the same witness marks, so we know all six valves on the exhaust side of things did hit their respective pistons as a result of the IMS bearing failure. So again, IMS bearing fails, your collateral damage ends up being a lot more extensive than the primary damage, and we have piston to valve clearance problems. Now here, if you look at this particular valve, it's the most noticeably bent, okay? It's not closing all the way here, all right? And that valve is noticeably bent. It may even be difficult to get that valve out of its place in the cylinder head because it may be bent so much that it requires the valve guide to kind of be removed or butchered or whatever to get it out of there. So there are cases where more things have to be done to facilitate a repair. Again, the valve guides are being replaced, the valve seats are being replaced. We are just keeping the actual castings of these cylinder heads for this particular R40 engine. Now, that may change later down the road with R40s. There's always options, there's always things that changes. So none of this stuff is written in stone. It's what I'm doing for this engine today in 2020. Okay, of course, Corona days, right? It's the coronavirus days. That's what we're doing today. So in 10 years from now, don't refer back to this video and say, but you said so-and-so. I said everything constantly changes, and that's the only thing that ever stays the same. So the final step in preparation of these cylinder heads to meet the demands of the larger displacement, higher performance R40 street and track performer engine is going to be port work to the cylinder heads. Now, port work is something that a lot of times is done too extravagantly. People go too big with it. They have like a drag race mentality where they just want to put huge ports in there. They increase port volume. They decrease port velocity when they do that, all those sorts of things. We find that sometimes doing that work to a stock engine can actually make the engine make less power or move the RPM range so far out of the spectrum that you can't use the power you've created. So over the time, using the flow bench, using all these different tools, Lynn and I have worked together, giving information back and forth. Sometimes he'll make a change to a cylinder head. He won't tell me. He knows what it did on the flow bench. I see what it did on the dyno. I see what it did to the tune. And then I'm like, hey, what did you do to this one? And he says, okay, I did that. So obviously you noticed it, so it must work, okay? Otherwise, we're looking for things that we don't see because we're looking for them, or we see them because we're looking for them. So the idea here is we match these ports to the larger displacement engine, the higher compression ratio, and all the other things we're going to do to make this engine into what it is. So we're going to do work to the intake side of the cylinder heads, making those ports a little bit larger, working on the flow around what we call the bowl area, the back side of the seat. The higher performance seats we're using have a little bit of Venturi effect, things like that. We're going to work with those things to increase the flow of air from the intake side of the head through the combustion chamber and out the exhaust side. We're going to do that without creating any critical imbalances that are going to make this engine idle poorly, have bad fuel economy, or give you pretty much a bad driver's feedback from the engine. When I'm done with this thing, it'll idle like a stock engine. Nobody will ever know it's built, and it will perform at a level that most people simply could not use. All right, moving right along, and again, guys, remember, this is just one bank of the actual cylinder head components and all that. The others are over here behind me for the other bank. We tend to keep bank 1 and bank 2 separated the entire time that we're doing this process, and even during assembly. It's just what we do. So moving right along, these are timing chain guide rails, and over the years Porsche did make these better. These are what guide the timing chains on their way out to the cylinder heads. They look beautiful, they really do. It's kind of really going to be a shame to crush these with a tank, but it is what it is. We're going to do that, and these are not normal for 29,000 miles. Typically 29,000, these are worn even more than this. I mean, these are beautiful, and that's certainly something that we are going to replace, and the main reason why is because the factory has changed the material of these over the years a few times, and they've made them better. That's one thing the factory's certainly done. So one of these is top, one is the bottom. This one actually goes on the chain tensioner side. The chain tensioner rides here. And these look good, but they're another item that we throw away, again, whether they're good or bad. On the other side of the engine, I did notice that this one was chipped when I pulled things apart yesterday. So you see this portion of this is broken away right here. That portion has ended up somewhere else in the engine. And we see that sometimes happen as a result of a failure, but a lot of times it just happens because they made that too thin there with this particular material. So no big deal. This one is actually worn more than any chain rail in the engine, so it won't be quite as much of a shame to crush that one. But we never reuse these. I would never even do a repair of an engine and reuse these chain rails. We always throw these away 100% of the time. So moving right along here, this is the lifter carrier. This actually is what holds the intake and exhaust lifters. They kind of go in just like that. That is one of the exhaust lifters. This one here is one of the intake lifters. And if you guys ever want to see what it takes to assemble one of these engines, we actually have a Focus on M9X engine assembly, which is a video series that is sold by the Knowledge Group that takes you through the whole process of putting this engine together. 15 hours, 20 episodes of solid content like this with crazy amounts of attention to detail. We put almost a year of our lives into creating that. It had 400 hours of editing done to it, okay? Crazy amounts of time. So if you're interested, that's a great thing to purchase through the Knowledge Group. You can also buy it at Ellen Engineering and some other places like Pelican Parts as well. So long story short, this lifter carrier has some very strict clearances inside of it. And these clearances must be maintained, okay? This is an item that if it specs out the way that it should, it measures properly, it has not seen wear from foreign object debris, and it passes my test and passes my tolerances, then we will reuse this. The Porsche factory says this should be replaced in 100% of the cases, but I don't think that's the case because I bought new ones of these that measured more poorly than an original one. Okay? So I'm not one of those people that it's easy to tell me to do something. If you tell me to do something, I'm going to say why, and then I'm going to ask you to prove it to me. And I'm not going to stop until you do. But ultimately, I prove it to myself. So what I think matters with what I build. That's just what we do. So here with this, I'm going to look at all of the lifters. I'm going to look at the lifter bores. We're going to precision measure every single one of these. And we're going to even heat this thing up, see how it responds to being hot, because you can't just do these measurements sitting here in a 72-degree room, which is what we keep our shop at here at the training facility, because we're measuring things. All these things are measured at 72 degrees, and it stays that way. But we're going to look at this closely. We're not going to crush this with a tank because it probably is just as good as a brand new one as long as it didn't have any wear debris get through it. I don't think it did because this was such an instantaneous failure. Okay? So going back to the lifters themselves, the exhaust lifters in this engine, they are barely broken in. I mean, they look really good, but we're not going to reuse them because they've had debris pass through them. And even the most microscopic of debris will get in these lifters, and it's going to end up causing a problem. These cannot be really rebuilt, okay? So they can pose a problem. And we're not going to reuse those. They're actually the same as some BMW engines. These things are a dime a dozen, so we're going to crush these with a tank. Now on the intake side, these lifters are a lot more exotic. This is it works on a three-piece or a three-lobe, if you will, design, where you have an outer lobe and then the inner lobe. So this is basically the camshaft that would drive one of these intake lifters. And at different RPMs and loads and oil pressures, this center portion of the lifter will ride on that innermost lobe only, okay? Like this. That's kind of how it works in certain operations. and we go over that in our Focus on M9X engine assembly video series. Because of that, these are what we call nested tappets. They have a dowel pin here that aligns with a machine pathway in the intake side of the lifter carrier, okay? So this lifter is not designed to rotate during operation. This lifter is designed to do that. It is not nested, okay? The exhaust side is not nested, the intake side is. That means this intake lifter has to ride in the same location over and over and over again, and it also has to operate in and out, and it has to open and close the valve. Okay? So what we do with these is we take these apart, we ultrasonically clean everything, we inspect them, and we put these back together. These lifters are almost $200 a piece at our cost to replace these. So it's worth us to go in there and look at each one of these, make sure there's no debris damage done to it, make sure nothing is bent, nothing is damaged, nothing is cracked. Sometimes you'll have a crack that forms right here and right here on either side of this center piston. And I didn't see any cracks with these. Obviously 29,000 miles, never tracked. I would think that would be the case. But we know what we're looking at with these lifters. These can lead to misfires. They can lead to all kinds of weird problems for the intake lifters. So while we are going to crush the exhaust lifters, we're going to keep the intake lifters. All right, so moving right along, we have our camshafts. I've already looked at these fairly closely. They're beautiful. Again, 29,000 miles. I wouldn't expect anything less. These engines do not have camshaft problems. With these, with the R40 spec engine, I do not replace these camshafts with a higher performance camshaft. We are always able to upgrade and do that if an engine is going to end up seeing the majority of track time. I don't want to build this into a track-only type of engine. I want it to be very streetable because this car is going to be sold on Bring a Trailer. I want somebody to be able to drive this car every day and then also take it to the track. I don't want it to be the other way around where it's built for the track and then sometimes can go to the street. With this one, we're just going to alter our valve timing events when I assemble the engine to give us enough performance gain or difference to work along with our 400 cc's of added displacement, our port work that's going to be done to the heads and all that sort of thing. So again, these camshafts will be just proprietarily treated to some things that we've done. We're going to alter the cam timing when we assemble things, and we're going to work with them in their own capacity because they look like they're brand new, okay? And that's the same thing that we can hold true for a lot of the other components that we have left here from this cylinder heads in this set of assemblies. This is the vane cell adjuster. This is what allows for the variable valve timing of the intake camshaft. 29,000 miles, these really don't give problems, but we're seeing some of these with higher mileage starting to cause some weird diagnostic trouble codes and things like that as they're starting to stick and are starting to wear. People aren't changing the oil frequently enough, or they're continuing to use junk oil and it's causing problems internal with wear, okay? But we're going to keep that. It's kind of interesting that they had to put a yellow dot on this one. That's something I haven't seen in a long time. This engine is so clean inside you can still see some of the yellow factory paint marks from inside of it. Exhaust cam sprocket, this is the upgraded version. We're going to end up keeping that. It's not worn. It did not see any collateral damage from the failure, so we'll keep that one. We are going to take these 4 bolts and throw them away because these are disposable items. They'll be getting crushed a little bit later today. The bolts and these main caps that hold the camshafts into place are a sub-assembly of the cylinder head. They will be getting kept as well. And then our scavenge oil pumps. These go in the cylinder head. This one actually has some debris inside of it. You can see I cannot turn it all the way. It gets to a certain point and stops. You see that? It gets there and stops. So that tells me that this oil pump has gotten debris inside of it. These are very tight tolerances inside these pumps, and any debris that's generated from a primary or secondary collateral failure will end up going in this pump. The pump has such tight tolerances it does not allow for that to occur. It will lock up and seize. If it seizes a lot of times, it will snap off this drive tang that is actually driven by the exhaust cam sprocket like this, okay? And I'm going to just turn it a little harder and see if I can get it to go by. Nope. So that pump is going to have to be replaced. We'll have to replace this one with a new one. So that one is something that we will probably end up throwing away and crushing. However, I may end up keeping it because I might just want to keep it for a test part. Sometimes we build test engines, and one of these can be buffed on the inside and be okay just to be put together to die from some other form of failure that we have basically created on purpose. So camshaft covers, very simple. Those go onto cylinder heads. They actually house part of the main carriers, if you will, for the camshafts fitting into them. We have the solenoids for the variable valve lift and variable valve timing. These items are something that I would not replace at 29,000 miles in most cases. We can ultrasonically clean these and get any debris out of them. However, they are starting to get a little bit long in the tooth for age, time and service. So there's a couple more tests we will do to them. We might replace them, we might not. Okay, so these are an option that we replace on a per instance basis with all of our other engines here at Flat Six Innovations. Ironically, we can look here at the color and condition of the spark plugs. So these are coil packs, okay? And if you look here, we've got 3 dramatically different looking spark plugs, at least from my angle. Let me turn this around a little bit to the camera. So we can see that these 2 cylinders had a nice coloration. This one was a little bit on the rich side. If you look at the corresponding piston that went along with this spark plug, you would see that that actually had the most amount of carbon on that particular piston as well. Now, I want to look at this and see if they have any date codes on these. Sometimes they will. This one doesn't have a date code. This could be an original equipment spark plug. It's hard to say. I'll have to ask the owner if he ever had the spark plugs done. I do have a lot of service records on this engine, but these spark plugs for 29,000 miles look pretty good if they are the originals. Now, the coil packs, on the other hand, are always going to get replaced, and we'd be, crushing them as well. As a coil pack at this kind of mileage is something that you want to look at just from a time and service perspective. So we always look at these, make sure they're not cracked and things like that. I don't see any cracks in this one. However, they are dated from 2002, so these would be replaced because I'm not cutting any corners with this engine. I don't want there to be a misfire or something like that later on. Sometimes with engines that we build here, of course, we're worried about all the internals more than anything. So there are cases where we let the purchaser of the engine determine if he wants us to replace those or not if they're not cracked. I actually have an option for that. If they're not cracked and you want to replace them, you can. If you don't want to replace them, you don't have to because they bolt on with 2 5mm bolts from the outside. It's a do-it-yourself job. It takes a few minutes to do it. You don't have to tear anything down, so if somebody wants to save some money after they've already been bleeding hundreds of dollars every day for months at a time after building this engine, I don't make them do that unless they're cracked currently, and then they can replace it later on if they need to. So now we're going to move over to a few of the ancillary components on the outside of the engine. We're going to talk about those things. Those things didn't see any collateral damage as a result of the IMS bearing failure because they're on the outside of the engine, but we're going to talk about which ones of those are going to get kept and what we're going to throw away. We have a few ancillary items here I want to go over. One, we have the contents of inside the sump. These are the defoamers, or the anti-foamers, if you will, where the oil comes from the scavenge oil pumps back through a pathway and comes into this. It goes around a tangent inside and comes out de-aerated, okay? And when you move oil with a pump, it can pick up air, it can create an aeration problem that can reduce the film strength of the oil. These are known to have some problems. I've come up with a way to address some of those things so they don't come apart, they don't have issues. There are some kits that are put together to make this a different design like a 997. When I go over the assembly of this engine, we will be showing what we're going to do to address that from a starvation perspective. Okay, so that's what those are. Oil pickup tube and some things like that. Of course, the original sump plate, which we still have not cleaned. All that, the sump plate will be reused as part of most of the Stage 2 engines. With this particular one, since it's R40, I've got a proprietary sump plate that works with the R40 package, and I'll be using that one, which is a billet aluminum sump plate that's going to be pretty trick. You'll get to see that one. Here, this is the front console. So this is what holds the opposite end of the intermediate shaft. The non-problematic end goes into this, and then on this side, it houses the oil pump and a couple other things. Now, sometimes as part of a reconstruction after an IMS bearing failure, we have to replace this because it's seen trauma from debris going through the oil pump gears inside this housing, okay? The oil pump gears go in something like this, okay? They're driven by the intermediate shaft. And sometimes we see, if somebody continues to drive a car, that it will destroy the gears here, and it will destroy the housing where debris passes through those tight tolerances. With this one, the car was shut off instantly. It was not tried to be restarted, and these gears look perfect. A big bullet was dodged with this. Now, while I do have some options for oil pumps for purely track-driven cars, or what I would call a stage 3, where it's going to see more track time than street, as part of the R40, I'm going to end up keeping these components as factory because this one is going to be built to see mostly street with some track time. And somebody can drive the engine on the track as much as they want, but it's not going to limit what they can do on the street, and I think that's a key. With this one, this is basically the cover for the oil pump housing. It's also not damaged anywhere. I don't see where any debris has gone through this at all. I can still see all the machining marks in it. It is beautiful, has no problems. I did not even see any debris inside where the oil bypass is at the bottom here, which is typically an area where debris would like to collect. If there's anything there, it's very light and will be removed with the ultrasonic cleaning process. It's nothing of any consequence at all. There is an upgrade that we certainly believe in here. This is the oil bypass valve and its related piston. There's an upgrade to fit a 997 version of this, which we certainly like to do. It helps the oil pressure, it helps the behavior of the oil pressure gauge, and all that sort of thing. So this is going to go into the pile to throw away. We've seen these springs snap in half in operation. Engine loses oil pressure, and it causes a failure of the engine as collateral damage. So we're going to remove this spring and the valve, and we are going to crush them. All right, so we also have the original water pump here. Even though it's an ancillary item, it's something else that has never been replaced. It's not missing any impellers. It appears to be in good condition. The bearing is very tight. Does not have any problems whatsoever that I can see. I looked at it, and I did find a manufacture date of late 2002, so that would make this the original water pump. If you guys at home still have the original water pump on your engine, or if you do not know if you do, you need to confirm that. A lot of times they will have a manufacturing date somewhere on the pump. According to who manufactured it and when, it may change positions. But when you find that date, if it's more than probably 4 or 5 years old, you want to replace it no matter the mileage, because these water pumps fail, they take engines out. So we're not going to build an engine like the R40 and risk this cheap water pump. We're going to replace it with a genuine Porsche item, not just a OEM replacement, because I have learned there is a difference in these. And we're going to replace that as part of the R40 package. So I'm just going to finish up with some of the other ancillary items on the outside of the engine. This is our intake manifold. Now, what I'm doing with this R40 engine and what comes with the R40 in this particular trim level is an IPD plenum. The guys at IPD are great. We only use these on higher performance engines, and we also make some other modifications to the internals of that plenum to make it even better. And we're going to couple that with a GT3 throttle body, which is made possible by the IPD plenum design and the sizing of it. So that's something you're going to see take the place of this as we put the engine back together. A lot of people call this original T on the engine a restriction. So I don't feel there's any restriction there. I just think we can work on the short side radius of this and get even better flow. They're going to match with our ported cylinder heads, our larger displacement, our higher compression ratio, our altered cam timing, and all the things that make the R40 combination a truly developed high-performance engine, okay? So that's what's going to happen on the outside there. Now, Another one of the ancillary components that we have to think about is the heat exchanger. I'm going to be careful lifting this up because it still has some coolant and oil in it. Now, the job of this heat exchanger is actually to take oil and coolant and mix them together inside this exchanger and keep the coolant and the oil at a closer temperature. Some people call it an oil cooler, and it can be if your oil has a tendency to run hotter than the coolant, okay? But it can also be an oil heater if your oil is taking too long to warm up. And that's something that we see that this is better for in the wintertime, obviously, is doing that job. It is a much better oil heater than it is an oil cooler, especially in our environment here in Georgia in a day like today when it's 97 degrees, okay? So the problem with this heat exchanger or oil cooler is it has all sorts of little tiny holes and pathways inside of it. Each one of those have held the problematic oil that is laden with metal from our IMS bearing failure, okay? A lot of people would look at it, say 29,000 miles on an engine, reuse it, why not? All this thing is an oil filter, guys. This has filtered all that little tiny debris out that made it through the filter, and it is holding it inside to then be released in your new engine when you put it back together. So don't be stupid, okay? It's like a $300 part. We're going to crush this baby with a tank, and I'm going to feel real good about doing that. So again, want to thank you for coming yet again into my world here for this RenVision technical video, another in our series, a focus on IMS bearing failure. Now, of course, in this video, we learned about all these pieces behind me, what we're going to keep, what we're going to throw away, how they failed, how they didn't fail, how they wore, how they did not wear, all that sort of thing. And I hope I helped you understand a little bit more about what the Flat 6 Innovations engine program is all about. And I hope you enjoyed seeing those parts get crushed as much as me, because there's nothing that I hate more than a Porsche part coming back in a few years as a recycled. So certainly want to invite you guys to subscribe to our channel and want to really open our doors to you to be a member of the RenVision channel and the RenVision world. I want you to become a member of RenVision. That gives you a whole lot of added capabilities, because not only are you going to end up learning about new videos that come out, but you're going to get more of that exclusive type video technical concept stuff that we want to share with everybody. So we're trying to grow this. We're trying to bring to you that direct, firsthand, real-world experience that I get to see every day. And without me showing you, all you're going to have to listen to is a bunch of guys out there that don't know what they're talking about, because they don't know what they don't know.